Hi guys, today we're going to look at section 10.3, which is on polar coordinates. Now, normally when we talk about the coordinates of a point, we talk about its x-coordinate and its y-coordinate. You know, starting at the origin, how far over do we go and how far up do we have to go to get to a certain point? Well, polar coordinates are just another way of describing the location of points. For instance, if we were talking about, say, this point, let's say this point here. We describe that point by two things: how far it is from the origin and what this angle is. It goes up to here. So notice this is like a piece of polar graph paper I've got here. It's actually just a screenshot of Desmos, but anyway, if you look at that point, it lies on the circle of radius 2 right here. And its angle, it lies on this ray here that has an angle of pi over 3. So this purple point would have coordinates 2 pi over 3. And just to pick another point, this point here, this green point, that lies on, well, its radius, or its r, is 3. And it lies on the angle 3 pi over 2. Now, one kind of interesting thing about polar coordinates is every point actually has many different names or many different coordinates. Like this one up here that we said was 2 pi over 3. We could also call this the point 2, and instead of just going around pi over 3, we could go all the way around and then up to there. So we could also call it 2, and then let's see, that would be pi over 3 plus 2 pi. It's the same as pi over 3 plus 6 pi over 3. So that would be 7 pi over 3. And of course, we could add on an additional, we could say go around once, twice, and then go up to the point. So we could also call it 2. Then just add another 6 onto the 7 and get 13 pi over 3. And you could also go backward. Instead of coming over here, instead of going up to pi over 3, we could go backward by that angle. Make the letter G accidentally. So what would that be? That would be pi over 3 minus 2 pi. So that's minus 5 pi over 3, right? No. Pi over 3 minus 2 pi. That's minus 6 pi over 3. But yeah, it's minus 5 pi over 3. So interesting thing there is, points have a lot of different coordinates. Now, typically, the one that we're going to want is going to be this one here. The one where the angle is the smallest positive angle that we can use. There is one other thing you can do. You can have a negative r. Now, I know earlier I said that r was the distance from the origin, but you can also think of this as, you can think of it as like starting with a little arrow or a spaceship or something that sits on the origin. I'm going to start with it pointing in that direction. And to denote that purple point, you can think of it as rotating. You can think of it as rotating up toward here. And then going forward to the point. Well, another thing you could do is call that negative 2. And instead of the spaceship pointing at the, instead of pointing at the point, it points in the opposite direction. And then it backs up to the point. So if I wanted to call that negative 2, then I would have to make this 4 pi over 3. You can think of it as basically, maybe instead of a spaceship, maybe I should make a little tank or something that's sitting on there. You turn it around 180 degrees away from where you want to go, and then back up to it. So in a similar vein, this green point down here, you can think of it as instead of instead of starting here and going down, think of it as starting here facing this direction and then backing up. So that would be -3 pi over 2. All right, so I've done all these examples on here, and this sort of codifies things. These rules. It says the point r theta and r comma theta plus 2 pi n are equal for integer values of n. In other words, you can add, and integers include negative numbers. So this means you could add or subtract 2 pi onto the angle as many times as you want to, and all that's going to do is change the number of times you go around the circle before you head out to the point. So in other words, you can always add a multiple of 2 pi on there. If you change the point r theta and minus r theta plus pi, those are equal. And that's what I was just talking about with it backing up. The only other thing is if the radius is, or if r is 0, then the point 0 theta is the origin for all values of theta. Because it's like you start here, and then it doesn't matter what direction the spaceship's pointing in. If you start at the origin and you don't move anywhere, you're still at the origin. All right. So anyway, let's look at, well, I've got a few examples here. Let's look at those. This first one, well, all of them say, for each point, find a set of coordinates with positive r and theta between 0 and 2 pi. All right, so this first one is 3 and then 11 pi over 3. Well, all you have to do here is, since the 3 is already positive, for this one you just do 11 pi over 3. I'm even going to leave the pi off. I'm just going to subtract off 2 until I get something that's between 0 and 2. So 11 over 3, let me just grab a fraction calculator. 11 over 3, I could do this, but subtract 2, I get 5 over 3. So this is going to be 5 pi over 3. And if we come up here, 11 pi over 3 would just be the same as 5 pi over 3. Coterminal with 5 pi over 3. All right, this next one, what I want to do with it, first let's make the r positive. So I'm going to change this to 2. Then I'm going to add pi onto this. So 7/6 pi plus pi, so that's 13 pi over 6. Then I'm going to subtract 2 pi off of this number because that's bigger than 2 pi. If I subtract 2 pi off of that, I'm left with 2 pi over 6. And I'm going to do the same thing over here. I'm going to change this 1 to a negative, or -1 to a positive 1. When I do that, I'm going to add pi onto here. Minus 14 pi over 6 plus pi. Let's see. Minus 14 pi over 6 plus pi. So that's going to add 6 onto that. So 8 pi over 6. Or I'm sorry, -8 pi over 6. Now I need to add 2 pi onto that. So that's 12 pi over 6. So it's going to be 1 comma 4 pi over 6. And what is 4 pi over 6? That's pi over 3. I'm just going to erase that and rewrite it. 4 pi over 6 is 2 pi over 3. So anyway, that's all there is. Just you know, if you change the r from positive to negative, you have to add pi, and then you can always add any multiple of 2 pi onto it without changing the direction of the angle. So I want to talk about converting between polar and rectangular, but we'll do that in the next video.